Good morning, dear students, and welcome back to our online class. We are doing chapter number 9, Carbon and its Compounds. And we have learned in our previous class some basic details of carbon, its importance in our everyday life, and why there is a need to study carbon as a separate branch. We learned about the symbol of carbon, atomic number 6, atomic mass 12 units, and it has a valency of 4. I'd like to repeat over here, carbon has a valency of 4 because some of you have written valency 2 as your answer of your previous assignment. We also learned about occurrence of carbon in the nature. They exist in free state as diamond, graphite, coal, and in combined state in different forms of compounds. Today in our class we are going to learn some more examples of carbon compounds, and we are going to see some other details about carbon. So without doing any lead, let us start our today's class. So we will start our class with examples of carbon compounds. Now carbon basically can form two different types of compounds, and they are organic compounds and inorganic compounds. Now organic compounds are those compounds which has to contain carbon as one of the most important element. Without carbon there cannot be an organic compound. Okay, organic compounds has to contain carbon. Now when carbon combines with hydrogen, only hydrogen, carbon and hydrogen only, then those type of organic compounds are called hydrocarbon. So hydrocarbons are compounds containing only carbon and hydrogen. Examples are methane, ethane, butane, benzene. There are more than millions of carbon organic compounds, and benzene you can keep on going, adding increase the number of carbon along with the number of hydrogen. After benzene we can write let's say butane, pentane, ethane, hexane, decane. We can keep on going. Okay, now if with hydrocarbon, CH3 is hydrocarbon because it is made of hydrogen and carbon only. So if with this hydrocarbon we have another group OH, this OH is an alcohol group. So this whole organic compound will be called alcohols. Okay, so along with hydrocarbon, if some other groups are attached, for example here we have alcohol group, then that group will give the name of the compound and they are called alcohols. And this is an example of methyl alcohol. In the same way we have another example of alcohol, ethyl alcohol. Now again in the same way, if with hydrocarbon CH3, this is hydrocarbon. Now if we have acid group, the organic acid group are COOH. The organic acid group is COOH. So if with this hydrocarbon we have acid group, organic acid group, then those compounds are called acids, organic acids. Here we have acetic acid. This is another acid with carbon and hydrogen. We have acid group COOH, and this is called formic acid, the acid which we get when when ants bites us and we feel itchy. That itchiness is due to the presence of formic acid. Other example of organic compound can be glucose, sugar, carbohydrate. So these are all organic compounds. Now let's go to inorganic compounds also. Inorganic compounds does not necessarily contain carbon as the important constituent. Okay, so inorganic compounds may or may not contain carbon, but organic compounds has to have carbon as important element. Okay, the only exceptions are carbon dioxide. Although this has carbon and oxygen only, both are non-metals, it is an inorganic compound. Carbon monoxide is also an inorganic compound. Okay, they are not organic compound. Carbon dioxide and carbon monoxide are not organic compounds, they are inorganic. Now inorganic compounds are mostly formed by metals and non-metals. Okay, so here when carbon combines with oxygen and metal sodium, this forms an inorganic compound, and the name of that inorganic compound is sodium carbonate. Carbon combines with hydrogen, oxygen, and with sodium, so it is sodium bicarbonate, the substance which we use to bake our bakeries. Carbon combines with oxygen, again with metal, calcium, so this is calcium carbonate, and so on. So the basic difference between organic compound and inorganic compound is organic compound must contain carbon as the important element, whereas inorganic compound, they need not contain carbon as the important element, although there are inorganic compounds which contains carbon combined with metals or other non-metals. Okay, the exceptions are carbon dioxide and carbon monoxide. Now there are large number of organic compounds around us, and still new organic compounds can be prepared in the laboratory. Now, how is this possible that carbon alone can form millions of compounds around us? This is possible only carbon has special properties apart from, if compared to other elements. There must be some special properties. Then only carbon will be possible to form millions of such a huge number of compounds around us. And that is true. Carbon possesses two unique properties, two very unique properties, due to which carbon forms huge number of compounds around us. And those two special properties of carbon are, number one is catenation. Okay, this catenation is the property of carbon due to which it can link with carbon atom, another carbon atom, or with other different atoms in a long chain. So carbon can form a long chain by attaching one carbon with another carbon and so on, like this. This is carbon atom, so the one carbon atom can combine, link with another carbon atom. This carbon can link with another carbon. In this way they can combine with any number of carbon atom, forming a long chain. If we have only 3 carbon, 1 2 3 carbon atoms, so this will be another compound. If another carbon comes over here, now this will form another compound. If another carbon gets linked, this will be now another compound. So in this way, now this is a straight chain. Now they can also branch over here, they can also join another carbon over here, so they can form a chain in different ways. They can also form a ring, like benzene. In benzene we have carbon like this connected to each other, forming a ring. So they can form ring closed structure also, they can form open straight structure also, or they can also form a branched structure. So they can combine, link with each other in any fashion, and this property enables carbon to make huge number of compounds. This is the first property. Second property, which is not mentioned in your book but I would like to tell you, is tetravalency. Tetravalency. Tetra means 4, valency, you know, it is the combining capacity, and the tetravalency or the valency, we learned earlier the valency of carbon is 4. So the tetravalency is the ability of one carbon atom to combine with 4 other different atoms. So since it has the capacity to combine with 4 different types of elements around it, therefore carbon can form huge number of different compounds. So these two properties, number one catenation and number 2 tetravalency, these two special properties of carbon enables carbon to make huge number of compounds, and especially organic compounds. So now let us see the allotropes of carbon. Now before going to allotropes of carbon, we have to understand what is allotrope, okay, and what is allotropy. So let us try to understand allotropes of carbon now. Now, allotropes of carbon, the existence of an element in two or more forms. If the same element, if the same element can exist in two or more forms, different forms, in the same physical state, then that is known as allotropy. What is allotropy? Allotropy is the existence of an element in two or more forms in the same physical state. Same physical state means if the element is solid, then its other forms also exist in solid form. If the element is in gaseous form, then it must have other forms in the same gaseous form. Okay, so it should not be one form in solid, another form in liquid, and another form in gas. For example, water can exist in three different physical states, that is solid ice, liquid water, and water vapor. But these three different states of water are not called allotropic form. They are different, they exist in different state. So to undergo allotropy, an element must exist in same physical state but in different forms. Same physical state. If it is in solid, all the state has to be different forms, has to be in solid state. Am I clear, boys? So the existence of an element in two or more forms in the same physical state is known as allotropy. And the different physical forms of the same element in the same physical state are called allotropes. So now carbon can exist in two allotropic forms, and they are the existence of carbon. Allotropic existence of carbon are: number one, crystalline form. It exists in crystalline form. And another one is amorphous form. Now let us try to understand what do we mean by crystalline form and amorphous form. Crystalline form means they exist in regular definite shape. Okay, they have regular definite shape. Their structures are not irregular. They have very regular structure. So if a carbon exists in regular shape, then that particular form is known as crystalline form. For example, diamond has a regular shape, definite shape. That's why we find diamonds in crystal form. Graphite, this lead, pencil lead, also has definite regular shape. That's why graphite is also crystalline form. Fullerene is another allotropic form of carbon, okay, which also has a regular definite shape, and therefore fullerene is also crystalline form. So we find carbon, three types of carbon in crystalline form, and they are diamond, graphite, and fullerene. Now let's go to another allotropic form of carbon, that is amorphous form of carbon. Now amorphous form of carbon do not have regular shape. It do not have any regular shape. Okay, for example, charcoal comes in different shape. Coke also comes in different irregular shape. Lamp black also can be irregular. It does not have any regular shape. Gas carbon is also a irregular and therefore amorphous form of carbon. So these are the two allotropic forms of carbon, and the two allotropic forms of carbon are crystalline form and amorphous form. And these are the examples of crystalline form of carbon, and these are the examples of amorphous form of carbon. This allotropy phenomenon or property is possessed by carbon, okay, and this property of allotropy is also possessed by some other elements, and they are phosphorus and sulfur. They also exhibit allotropy. That means they also have their allotropic form. They also exist in different forms in the same physical state. So with this, now we have come to know that diamond is a crystalline form of carbon, which is one type of allotropic form. Now we'll try to see few details about diamond today. Okay, let us go one by one. Now diamond, we all know diamond is the purest form of carbon. Okay, and we also know, we have been learning this, diamond is the hardest naturally occurring substance present on our planet Earth. Now diamond, carbon, although it is non-metal, also poses, this is also the property of metals, it also is lustrous, and this is also the property of metal. Carbon being non-metal, it also possesses some properties of metal. Lustrous means it has shiny nature. Now diamond also exists in what form? Crystalline form. That's why this is, diamond is the crystalline form of carbon, allotropic form of carbon. Okay, so let us remember that diamond is the purest form of carbon. It is the hardest naturally occurring substance. It is lustrous, it shines, and it is crystalline in nature. Now how can this diamond, or how are these diamonds formed? Because diamond is one form of carbon, so there are other types of carbon also, but how this diamonds gets formed, let us try to understand that in brief. So carbon can form diamond, we all know now that. Now these diamonds get formed by two ways. One is by natural process, and another way is by synthetic process. Now natural process takes place in the nature itself. By the name only we can say that it is a natural process taking place by itself in the nature. How in the nature this diamond gets formed? This carbon which lies deep under the Earth's crust. Now under the Earth's crust we have huge extreme heat and pressure over there. Now this extreme heat and pressure compresses the naturally available carbon under the Earth's crust and converts them into diamond. And this is the reason we get diamonds in the shafts of extinct volcanoes. Now diamonds are found over there, but it is very dangerous, risky job to collect diamonds from these shafts of extinct volcanoes. That's why these diamonds are very precious. In the laboratory also diamonds can be manufactured, and that process is called synthetic process. So how in the lab we can make diamond? Again we have to follow the same process which happens in natural process, and that is we have to compress carbon under extreme high pressure and temperature. So by arranging conditions such as extreme high pressure and temperature, we can compress carbon atoms. We can bring these carbon atoms together very close to each other and force them to arrange themselves in such a way that they form diamond. Okay boys, so these are the two ways by which diamond gets formed. They are natural process and synthetic or artificial process. Now we know that in order to form diamond, carbon atoms needs to be compressed. They need to be compressed. Compressed means they need to be brought closer to each other. Therefore, what can be the structure of diamond then? Since the atom must be very close to each other, so what kind of structure do they form? Let us see that. Now diamond forms a regular tetrahedron structure. Tetrahedron, tetra means 4, hedron means headed or direction wise, regular tetrahedron. So this is the tetrahedron structure of diamond. So in the tetrahedron structure, one atom is in the middle and the 4 atoms are placed at the 4 corners. These are the 4 corners, tetra. Okay, so one carbon atom, this is at the center, and this is another carbon, this is second, third and fourth. They are placed in this, they are arranged in this way, and this 2 carbon atoms are joined to each other by a chemical bond, that is covalent bond. This